Open on the right-hand side of your screen is the resource widget, and below that is the attendee chat where we can communicate and interact with each other during today's course. In the center of your screen is the media player, and below that is the Ask a Question widget. You are able to resize, minimize, and move those widgets to your liking on your screen's real estate. And then for those of you that are subject to regulated status, the chat feature should not be used. The audience may include customers, vendors, or competitors of you or your employer. If you choose to take advantage of the interactive features available in the course, and we hope that you will,
into security within your AWS account and how it works. We'll also talk about security across multiple AWS accounts using tools like AWS organizations or cross-account roles as well. Those are just a few of the things that we'll be learning about here over the next few hours. But before we jump into all of that and get the ball rolling here, there are just a couple things I would like to mention. So, as Lindsay mentioned, we're going to have a recording of this course, and you're going to be seeing me do a lot of hands-on demonstrations inside of the AWS console. I would just like to encourage you to use the recording, right? So I don't typically recommend that you try to follow along with me here as we're going through the live course, because it's just going to move a little bit too quickly to keep up in your AWS console. But a great way to get the most out of this course is to just kind of tune in to the live course today, learn as much as you possibly can, and then eventually, repeat the lab exercises that I'm going to show you inside of your own AWS account using the recordings. Right, the recordings are a great way to kind of do that stuff. And in addition to that, I always encourage all of my students in any of these courses to kind of treat a little bit of a personal preference thing, but when I attend a course like this, I like to have a goal in mind, right? So think about what you'd like to accomplish here. Are you, prepping for certification? If so, you should be taking, a lot of notes, and because as much of what we're going to learn here today is applicable to multiple AWS certifications, like the Solutions Architect Associate, SysOps Administrator Associate, the security specialty, of course, is all stuff that we're going to be learning here today. So it's going to be applicable to multiple certifications. So just think about what your goal is. If you want to make sure that you do all of the hands-on stuff that I teach, that's a great goal. If you want to take in-depth notes and use those as a preparation tool for your certification, that's a great goal as well. So yeah, it's always good to start with your objective at the front of your mind. So yeah, with that being said, though, let's go ahead and jump right in here. There are too deeply into any of those topics specifically. We're more focused on permissions and overall security. Final thing I'll just mention, if you have questions, there is a Q&A feature that you can use to ask those questions. That's the ideal place for questions because it'll let me know. If you have a question, it'll give me a little alert so that I can answer your question quickly. You can also use the attendee chat feature as well. But just understand, if you're asking questions inside of the attendee chat, I may not answer them as quickly because I don't get that little alert when you ask those questions. Responsibilities, right? And their responsibilities are kind of like that builder. They're going to build you a secure house. They're going to provide physical security of their data centers. You don't have to worry about who's coming and going in those physical data centers. If there's old hardware that is at the end of its lifespan, but that hardware may contain sensitive data, well, it's up to them to get rid of that in a secure manner. If If we need a border firewall to do things like DDoS mitigation or recognizing attack patterns, things like that, that's something that AWS will do. So AWS will provide you with security of the cloud. You are responsible for security in the cloud. So for example, if you create an EC2 instance, and maybe it's got the Windows operating system, and maybe you never bother to update it or patch it, or you install applications that are security risks. Well, AWS can't control that, right? Maybe you have security group rules that are overly permissive, that are allowing all kinds of traffic in that should not be allowed in. Well, again, that's something that AWS has no control over, right? And maybe you're setting up IAM permissions that are too permissive. Maybe you're not embracing this principle of least privilege that we're going to talk about here today. If you don't use the tools provided for you responsibly, then your AWS account is not going to be secure. And that can lead to all sorts of terrible outcomes. So we're going to talk about what some of those are and some of the easiest ways to avoid them, right? And a lot of these attacks come down to opportunity. So if the opportunity is a very challenging one, you don't see a lot of people trying to steal the Mona Lisa from the Louvre, right? Because it's extremely secure. You don't see a lot of people trying to get that kind of high value target. But, if you own a store and you leave the door wide open and nobody's there, yeah, you're probably going to have some stuff that gets stolen. So making those opportunities, minimizing those opportunities, making it as difficult of a target as it can possibly be is an important principle that we need to embrace here. And so let's start with the root user, right? And the root user is the user that is automatically there for you when you create an AWS account. When you create your AWS account initially, you're going to have to provide an email address. That's the root user. And that is the all-powerful user that has access to 100% of everything in your AWS environment. And so we want to think of that root user as, the most critical thing to protect, right? We have to be very cautious with that root user. And really, we should not be using that on a day-to-day basis. So once we get our AWS account set up, we should be using IAM, right? We can use the root user for the initial configuration of our AWS account. Then it should basically be locked away. And multi-factor authentication is an absolute must with the root user. We have to have multi-factor authentication enabled. And so it's just one of the most critical things. And one of the things that I find that people kind of think is, well, maybe I'm going to open my own little AWS account and I'm going to use it to follow along with Rick's demos here, right? So Rick demonstrates something, I try it in my own AWS account, but I'm not really using that account for anything important. So I'm not going to bother setting up multi-factor authentication. That's a bad decision. And I think of it this way. Let's say that our AWS account is giving access to massive amounts of compute resources, storage. You can create serverless functions. You can create containers. You can do all this cool stuff. If I had a data center that was capable of doing all of those things, I wouldn't leave the door unlocked, right? Because people could take that over and do really bad things with it. Well, if they take over your AWS account, they can do really bad things. And you're going to be responsible for all of the billing implications of that, right? Let's say they launch thousands of virtual machines to launch an attack against somebody else. They're doing that inside of your AWS account because it's not properly secured, right? So multi-factor authentication is absolutely critical on the root account. That's always the starting point, right? You want to make sure that multi-factor authentication is enabled on your root account. Now, I see a question very early on about Control Tower here, and you don't necessarily need to set up Control Tower. Control Tower is a great way to manage multi-account environments with a landing zone that is automatically well architected. It's going to use AWS organizations. It basically uses these predefined blueprints that will set things up according to the best practices. It'll use guardrails to make sure that you are in compliance with whatever regulatory requirements you have. So what you're going to see here in this course, we're going to set it all manually because you need to know all the ins and outs of specifically what you're working with. But one of the things that we will adhere to as we work through this content is we will adhere to the principle of least privilege. So the idea here is you want to give a user or entity access to what they need. You know, if they need specific data, if they need to be able to manage EC2 instances or containers, or set up Kinesis to handle streaming data or whatever, we'll give them access to those solutions and that data and nothing else. And like I said, I'm a fan of an analogy. I have a little workshop in my basement where I have power tools and table saws and stuff like that. And I have a couple kids in the house, so we go according to the principle of least privilege. I specify you're allowed to use screwdrivers. You're allowed to use this tool and that tool. You can use my hammer. You cannot, but I don't list everything that they can't use. Right? I tell them these are the 5, 6, 10 things you can use. Everything else is off limits. That's the principle that we want to go with. Now, it may be inconvenient at times, right? There's always this relationship of security with convenience. It's always an inverse relationship. So you've probably experienced this where you have situations that are frustrating where you have to keep on logging in, or I just want to log in and check my email, but I need to put in a code coming from my smartphone or something like that. There's always that little bit of an inverse relationship where the more secure you make things, the less convenient those things tend to be. But it kind of beats the alternative of having things that are not secure. So the idea here is, hey, if we're not giving people enough permissions, then we're going to get requests. They're going to ask for those permissions that we need, and it's a lot easier to give somebody some additional permissions than it is to undo some terrible thing that they've done because they had permissions for something that they should not have, right? And if you think about a lot of the big problems that you may have experienced over the years with anything information systems related, at least for me, I know personally, a lot of those big problems were due to users doing things that they should not do, and maybe they shouldn't have had the capabilities to do to begin with, right? So that's what we're looking to avoid, is giving people permissions that they really don't need. So we are going to try to adhere to this principle of least privilege, right? All right, so let's talk about the basics here, day one. And by the way, multi-factor authentication is, you'll hear me say this multiple times, is all the permissions that the dev guys should have. I'll put that user in the dev group, and then they'll get those permissions. So I can then assign policies to my users and groups. Basically, the policies are going to govern what are they allowed to do? What are the actual permissions that those users or groups are going to get? Or those are the permissions that what our principals will get. right? We're going to talk about that term principals in just a moment. So the final thing is a role, right? So if I have a group of permissions, I want to kind of group them together and say, you know, if somebody's on the help desk team, they should get the help desk role. They should get a specific kind of curated set of permissions that should be applicable to all the people in the help desk team. Right? So that would be a role, be a collection of policies. And then the principal is, who are we assigning these policies to, right? So I could be giving an IAM user a set of permissions, a federated user. We'll find out more what I mean about that in a moment. I could be doing things like giving permissions to an EC2 instance. Right? I could be assigning permissions to different resources in my AWS account. Right? So there's different types of principals that we're going to apply here. I see a question. What do you think about multi-factor authentication with the vision of the man in the middle? I mean, no security solution is ever going to be perfect. But here's kind of the way I think about it, right? Would I want an ATM card that anybody could just simply use? Or would I want an ATM card that also requires a PIN? I'll take the one that requires the PIN, right? Because if I drop it, I don't want somebody to go clean out my my bank account. MFA is not entirely foolproof, but it makes it much harder to compromise my account, because even if somebody is a man in the middle and they manage to get my password, they can also maybe get my one-time passcode that's going to last for the next 2 minutes, right? But then that one-time passcode is going to expire, right? Now, there are certain types of man-in-the-middle attacks where you know, they could get your one-time passcode. Okay, let's go to the IAM dashboard. I'm just going to type in IAM up here. And we're going to go to IAM, and you'll notice that when we get to the IAM dashboard, my region is no longer Ohio, it is now global. Right? So anything that I do here in IAM is going to apply across all of my AWS regions. So IAM is global. It's not regional, it's global. And so let's see, a couple other kind of neat things here to take a look at. Here we've got this little URL. This is the sign-in URL for my AWS account. So I can give this little URL to users, and they can connect to it, and they can use their IAM user and password to sign into my account specifically, right? And you can see my account has an alias here. I can change that little alias if I want to name it something different. You can see that alias is right here in my AWS account. So yeah, I can take this URL. I can, if I do a new incognito window here, let's see, I should be able to paste that in, and it should bring me to the login screen. There we go. So you can see here that URL is taking me to the login screen specifically for my AWS account. All right, so that's the purpose of this little sign-in URL here. And a couple other things you'll notice right off the top, there's a couple of green checks here, right? The two green checks that are showing mean I've done at least two things right. So I'm off to a decent start. I've got at least two things right. I have multi-factor enabled on the root, and the root does not have access keys. I've never come across a good reason that the root user should have access keys, right? So yeah, we want to get rid of those. We want to make sure that our root user does not have those access keys. Okay. So, and you can see here, if we go to, where is it? They like to move stuff around on me. Where do they, that's not here anymore. They don't have it here anymore. Oh, there it is. My security credentials. Yeah, it takes me a minute to find things sometimes. If I want to change my root security credentials, I can click on this link. And here you can see my root user. That's my root user. I can do things like assign a multi-factor authentication device to the root user. And I can see my access keys here. And again, you can see I don't have any, right? I don't want access keys for the root user. Okay, so let's build from the basics here. We're going to start by creating a new IAM user. So over here on the left, you can see our little sidebar menu here. I'm going to click on users, and I'm going to create a new user. And the user, I'm just going to call it Rick Demo. All right, that's going to be my username. Now, this user in particular, I am going to give this user access to the AWS console, right? Which is what you see me working in right now. I'm working in the AWS console. The biggest, the most powerful policy that I can give Rick Demo, which is administrator access, right? And so, yeah, we'll give Rick administrator access. And we can also set a permissions boundary. So if we scroll down here, permissions boundary is a handy little tool that, I'd say probably doesn't get used a whole lot, but you can use these effectively. So with a permissions boundary, we have a user who maybe should only be allowed to work with S3, right? Or maybe only be allowed to work with EC2, right? This kind of goes along with that principle of least privilege, right? So I want to say, hey, Rick Demo is somebody who's going to be working in S3, right? So I'm going to say, no matter what permissions Rick Demo is granted, the boundary is they cannot have any permissions outside of S3 full access, right? So it's basically creating kind of like an upper limit on the permissions that this IAM user can get, right? And that will apply even if they're added to groups that have certain permissions that they shouldn't be getting. Well, this will prevent them from getting those permissions because they have a boundary on the permissions that they can possibly get. I'm not going to use a permissions boundary in this first example here, but that's the impact of a permissions boundary. Let's see, I see a question. Can we add admin access to a few users who manage admin access for the rest of the organization users? Yes. Yep. And you'll see there are specific user permissions. Let's see if I can find it real quick here. There's organizations admins as well. So if you're going to be managing, multiple AWS accounts, there's permissions that are specific to that as well, right? Okay, so I'm going to give Rick Demo administrator access, and I'll click next here. And yeah, it's going to give me a nice little summary. Oh, what did I do? I gave EC2 read-only access as well by accident here. Let me go back and find that EC2 permission that I accidentally selected here and uncheck it. There we go. Okay, so here's my little summary. Rick Demo is my new user. They're going to get administrator access permissions applied to this one specific user. And I'll click Create User. And there we go. There's my user, Rick Demo, and I can see Rick Demo's password right here. Right. So I'm just going to copy that, and I'm going to put it in a little notepad here off to the side, and so I don't forget the password that I gave him. And we're going to try to log in as this user. Right. I can get his password here, and I can get the console URL right here as well. So let's sign in as Rick Demo and see what the results are. I'm just going to sign out of my AWS account here. And I'm going to put in that little URL, my Rick Crisci Architect URL. And I should be able to put in my IAM username, which is Rick Demo. And I should be able to put in my password and sign in as that user now. And there we go. I'm in as my new user. So, so now that I've signed in as that user, I have the ability to do anything that the admin access can possibly do. Right. So, for example, let's go to IAM, and maybe I want to create a new user group. Right. I can do that. Right. And by the way, look what it's alerting me to right away here. This user does not have multi-factor authentication. That's a bad idea. This is a full admin. I should take care of that right away. Right? I should give them MFA. What will happen if I allow a user to create their own password? Yeah, they can be allowed to create. Oh, you mean on the initial login? So we can do that. We can allow them to create their own password on their initial login. I'm more a fan of the approach of just give them a temporary password and force them to change it. Will you be able to see others' passwords if the user created their own password? No. If a user creates their own password, I cannot see it, even as a full admin. You can't see those. Yeah. Yeah, that would be a big problem if you could. So then you could sign in as any of those users and just do whatever you want as them. So let's create a new group. Right? I'm just going to ignore this MFA thing for a moment here. But I could show you how to actually, let's do it. Let's set up the MFA on this user. Let's go for it. Why not? So I'm getting this warning here saying, hey, you've got this admin user, and it would do this for any user, but it's especially a concern because this is full admin, right? So I can click add MFA, and what I could do is I could create a new MFA device. I'm going to just call my new MFA device Rick Demo. And what is it going to be? What kind of physical multi-factor authentication device is it going to be? Do I want them to authenticate using their face? Right? We can do facial recognition now. That could be our second factor of authentication, right? Or fingerprint. Do I want to give them a Gemalto physical security device, right? So if you've ever used like RSA, like an RSA key fob, that's kind of similar to this, right? It's something physical that they will have that'll always be, like generating new little passcodes for them, right? So we could use a dedicated physical security device for them, or we could use what I typically use, which is an authenticator app, right? So on my smartphone, I've got Google Authenticator installed, and that's the one that I like to use, Google Authenticator, and I can say, hey, let's associate this user's account with the Google Authenticator app on their personal phone or their company. You tell your son, hey, you're allowed to go to all the houses in the neighborhood, all right? Oh, and by the way, you're allowed to look at all of the roads in our neighborhood, right? Well, those are two things that you're allowing that kid to do. You're not explicitly denying anything. the two policies that I've just created. Team admins EC2, and right, where can they do these things? Which EC2 instances? And again, we've got the star here. That's essentially saying they can do these actions on all EC2 resources, right? So what can they do? Where can they do it? And are we allowing or denying these actions? We're going to allow them. But you can see here, this particular policy has a condition, scope, and we can make a really fine-grained permission using conditions. All right, so I'm going to sign back into my AWS console here, and I'm going to do something that I told you not to do. I'm going to sign in as the root user. So I'm going to sign in as root here real quick. I'm going to put in my MFA code.
Hello, everyone, and thank you for joining the online training course, Clean Agile. My name is Joan. I'm with O'Reilly. I'll be your facilitator. And today we welcome our instructor, Robert Martin, also known as Uncle Bob.
So let me address that
Robert has
question
been
real quick.
a programmer since 1970. He is the co-founder of CleanCoders.com.
That's pretty cool, right?
Offers
I
online
use
video
this a
training for
lot
software
when I'm doing like
developers,
Python
and is
coding or
also
something
the
like that.
founder of
It's
Uncle
extremely
Bob
valuable, right? Yeah, if you want to document what a policy does, hey, why not let AI do it for you? But again, I look at it as a first draft. When I'm doing like Python code, you should be able to read and understand the policy. That's the ideal outcome here. But I could also say, summarize what this IAM policy does. And then boom, paste it in there. And it should be able to read through it, figure out what it does. Let's go to JSON.
Hiring for AI and ML roles has been increasing by 30% each year after the pandemic, while demand for
sell first and then design the product. Highly important for teams to have as their number one guiding principle.
How do you see Gen AI?
This is an evolving area. Both our customers and us are learning about generative AI. Low latency kind of solutions. Many people are bringing, developer shows up with their own database.
In building these high performance teams.
It is the greatest enemy in some ways of wonderful technology.
From the tech industry to get their unique perspectives and insights. Today's guest is Murali Tirumale, GM Cloud Native Business Unit, Portworx at Pure Storage. He's a serial entrepreneur and one of the nicest persons I have met. Murali, it's great to have you on my show.
Johnny, it's great to see you. It's been a while, so it's a pleasure to talk to you again.
Murali, let me start by asking you, what are the trends that you are currently seeing that are shaping the cloud native storage landscape?
You know, one would expect that with all the activity in cloud, in the cloud native world, that I would have some. The best things in life are pretty simple, like simple chocolate ice cream versus all these fancy flavors. And really, in the end, I think what we have is two things that are happening, right? I think of them as bigger and higher. So
और गाइस, तो इस वीडियो में हम लोग बात करने वाले हैं डिजाइन पैटर्न्स के बारे में। किया तो वीडियो को लाइक कर दीजिए अपना अच्छे एग्जांपल के हेल्प से। देखिए, समझिए, जब हम कोई सॉफ्टवेयर, बहुत सारे डेवलपर्स होते हैं उस प्रॉब्लम को सॉल्व करने के लिए। सो लेट्स सी कि ये हमारे सारे डेवलपर्स हैं। मैंने 3 डेवलपर बना दिए, आप अलग अलग जितने मर्जी आपके टीम में हैं, बहुत सारे हो सकते हैं, ठीक है। तो ये सारे डेवलपर्स हमारे पास अवेलेबल हैं। अब हर
Hi everyone, welcome to Java Techie. In this tutorial, we'll discuss what is Saga choreography design pattern and how to handle transaction using this Saga pattern. We'll consider a small use case and we'll try to understand what exactly this Saga and how we can implement it. Okay, so let's get started. Used to demonstrate more on transaction feature in monolithic as well as microservice application. Okay, so if you can see this use case, when an user placed an order will be fulfilled if the product's price is within the user's credit limit, otherwise it will not be fulfilled. So this is the simple use case. So let's try to map this use case with monolithic approach. Then we'll see how difficult it could be in dealing with transaction in the distributed microservices system. Okay, so if you can see this diagram, we have order service and payment service, and both the service pointing to the single database. So this is very easy to implement in a monolithic application. The entire workflow can be considered as a single transaction because both the application point to the single database, right? And also it is easy to commit rollback when everything is in a single database. Let's say, for example, order service send request to create a order. Now again, payment service will process the payment. So we call the process payment. Okay. In case there is some failure while processing the payment, then the entire data will be rolled back. Not a single data will be inserted to NADB. That is how the transaction handled in monolithic. And the Spring framework provided enough feature to handle the transaction in case of monolithic application. But microservices does not follow this principle. Microservices basically follow the pattern called database per service, where order service have its own database. Similarly, payment service have its own database. So if you observe, there is 2 microservices and they are pointing to 2 different databases. If it is a single database, then the approach will be same as monolithic, right? Now let's understand how we can handle in this microservices pattern where it already follow database per service pattern, how we can handle the transaction. So if you can see this diagram, order service has its own database which is responsible for managing the order. Similarly, we have payment service has its own database which is responsible for managing the payments. At the very first step, order service will receive the request from the user. Then again, order service will redirect that request to the payment service to validate whether that user have enough balance or not to check in the payment service. Now payment service receive that request and validate that user balance in DB. If he found that user have enough balance to purchase that order, he will deduct the amount from the DB and send OK response to the order service. Once order service receive this OK status, immediately he will complete the order. In case order service didn't receive OK status from the payment service, then we'll cancel the order. So this workflow is straightforward and very simple, right? But what if in future you want to introduce another service called inventory service who has his own database? So in that case, to check the product availability in inventory service, again order service need to send another HTTP request to check the product availability in inventory service, right? Which is not a good approach to design the code. Unnecessarily, for a simple requirement, we are firing n number of HTTP requests. So in future, again, you just want to introduce another service. From order service, you need to fire HTTP request to that particular service. And another problem I can say, order service always assume this payment service and inventory service is up and running. In case order service send request and payment service is not available that time, then it will be impact on your revenue, isn't it? So in this approach, we found two disadvantages. One, you need to fire n number of HTTP requests, and second, it will impact on your revenue if there is a application downtime, right? So to overcome this issue, microservices developer provided a pattern called Saga pattern, and we can implement this Saga pattern with two approaches. One is choreography approach and another is orchestration approach. So in this tutorial, we'll be discussing the choreography based approach by using event sourcing. So there will be no HTTP request call. We just need to go with the event sourcing approach with choreography. Okay. So now let's deep dive into choreography Saga pattern and its architecture. As you understand, there is two service, order service and payment service, and both have their own independent database. Okay. So once order service will receive the request from user, immediately he will produce an event to the Kafka topic, and the name of topic is order event. So immediately once he publish the event to the order event topic, payment service will consume that event. And again, payment service will take that request and validate in user balance table to check whether that user have enough balance to purchase that order. If he found that user have enough balance to purchase that order, immediately payment service will publish another event to the topic, and the name of the topic is payment event. Now to this payment event topic, again order service will consume that event. Okay. If order service found that response as a payment completed, then order service will complete that order, otherwise it will cancel the order. So if you observe in this choreography pattern, there will be no HTTP request call, right? Initially, order service publish the event to the order event topic, and payment service consume the event from the same topic. Then once payment service validate the request, again he publish the event to payment event topic, and order service consume the event from the same topic, right? So this approach looks good. Now let's try to sync this approach with one example. For example, let's say in payment service, we have two user ID 101, 102, and they are having balance 4000 and 2000. Okay. So let's say order service just publish an event with user ID 101, product ID something, and price is 3000. He just published the event with this order event topic, and immediately payment service will consume that event. He can see the entire message, and then payment service will take this request and check in user balance database. User 1 having balance 4000 and he is trying to purchase something 3000. It means he has enough balance to purchase that order. So payment service will immediately allow him to purchase the order and will deduct the amount. Now the rest amount is pending for user 101 is 1000. So immediately payment service after update the or after deduct the amount, he will publish an event to this payment event topic with the payment status success or completed, something like that. Once order service will consume that event with payment status success or complete, will simply complete the order and user will get the message something like this. Now for example, let's say user ID 101 again want to purchase something. So again user service or order service send the request user ID 101 and product ID something different and price is 1200. Now payment service again will listen to the same topic and he can view this message or he can view this JSON, right? So payment service will take this request and will go to the user balance table and check that user ID 101 having the amount 1000 and he is trying to purchase something beyond the amount. It means it exceeds the limit, right? So what payment service will do, immediately he will publish an event to the payment event topic with status failed. Now once order service will listen to that payment event topic or once order service consume that event with payment status failed, immediately order service will cancel that transaction or immediately order service will cancel that particular order and user will get a response like this. Okay, user ID this, payment status failed and order status is cancelled. So this is how Saga choreography pattern works. We'll try to implement the same replica of example. We'll create two service, order service and payment service, and we'll use the same scenario. Okay. And I just want to highlight the tech stack. We are going to use Spring Webflux, Apache Kafka, Spring Cloud Stream, Java 8, and also we'll use multi-module project so that we can reuse the component or classes. Okay. So these are the tech stack I'm going to implement in this Saga pattern. So if anyone not aware about what is Spring Webflux, you can check out my reactive programming playlist. Similarly, if anyone not aware about Apache Kafka, you can check out my Kafka playlist and Spring Cloud Stream video also available and same multi-module project tutorial also available in Java Techie. You just search with this keyword if anyone not aware about any of the context. Okay. So next what I am going to do, I'll just create a skeleton of the multi-module project. We'll just create payment service, order service and common DTO class so that we can reuse the DTO or event class. Okay, so I'll just create a skeleton of it and in my next tutorial we'll just add the implementation. Okay, so let's move to the IntelliJ IDE. Let's quickly create a multi-module project. Click on file, click on new project, then click on Spring Assistant, click next. Next I'll change the group ID com.javatechie. Then artifact ID I will specify Saga choreography pattern and same I just want to specify as my project name. Then change JDK version to 8. Also I just need to change the package com.javatechie.saga. Okay. So in this project type instead of Maven project just change it to Maven POM. Okay. So that it will create a multi-module project. Now click on next. So I just need to add dependency Lombok. We are going to use Spring Cloud Stream. So I will just use Cloud Stream. Then we just need to add Apache Kafka.
If you want to become a pro Python developer without having any prior knowledge on the subject, then join.
Okay, so you can use Spring for Apache Kafka. Since we are using Webflux, I just need to add web dependency, which will be reactive web. Also, we are going to use database, so I will add JPA. And I'm going to use MySQL, so I just need to add MySQL connector as well. Okay. So let's cross verify if we missed anything. Lombok, CloudStream, yeah. Now click on next. Just click on finish this window. So it will download the latest dependency. So yeah, it's in sync now. Just close it. Now we just need to create the modules. Okay. Just open this. You can see there is no src, right? Only we have the pom.xml, and in pom.xml we just added lot of dependency, JPA, Webflux, Stream, Kafka, right, and MySQL. That's fine. Now let's create the multiple modules inside this. So I'll just right click here, new, then I can see the option here, module, right? Just click on that and then just click on Maven, click next. So I'll just use the artifact something like order service. Here I just need to write the logic for only order related stuff. Now click on next, click on finish. Similarly, I just need to create another module. Let's say click next. I will name it payment service. Okay. Click next, finish. Similarly, I will just create another module where I will just write all the DTO class, so that while sending and or consuming the event, I no need to write those DTO class repeatedly in order service and payment service. I can maintain it in a common folder. So I'll just create new module, click next. Let's say common DTOs, click next, click on finish. Just enable this auto import. Now if you observe, we created three separate module, common DTOs. Now if you go inside this, you have src pom.xml. This is order service. You can find src pom.xml payment service, and this is the root pom.xml, right? So since this is the root pom.xml and Kafka and CloudStream related stuff, we just need to perform inside order service and payment service. What I will do, I will just copy this dependency. Okay. I'll just remove it from the root. In root, I will just keep the test related dependency, and all the actual dependency I will move into the uh, order service and payment service. So let me copy this. I just need to copy up to this Lombok. Just copy. Go to the order service pom.xml. I'll just add a section called dependencies. Inside that, I can copy this dependency. Okay. Similarly, go to the payment service pom.xml, and I will just add this tag dependencies. Then I will add this dependency. Now go to the what is that, root pom.xml, and remove this dependency. Okay, so if you observe, now in this root pom.xml we have only test related dependency. Fine, just save it. Now let's close all. Then what we can do, if you'll go to any of the dependency, let's say order service pom.xml, if you observe, the parent is our Saga choreography pattern. This is your the parent, and we added all the required dependency. Okay, similarly common details and order service payment service. Now let's go to the each service, order service and payment service. We just need to write the main class manually, because we didn't create this as a Spring Boot project, right? We just simply create it as a Maven project. So let's go to the order service, go main, then I will just create a package here. Let's say com.javatechie.saga.order, something like that. Okay, now click on OK. So I'll just create a class here, new Java class. Let's say order service application. I just need to annotate here @Spring Boot application. Then I just need to write main method, and I just need to write Spring application dot run and give the class name dot class. Fine. Similarly, I just need to create another package in payment service as well. Okay, go inside the payment service. I'll just go to src main, then I'll just create a package here, payment, something like that. Okay, then I just need to create a class, main class. I'll just name it payment service application. Then I just need to annotate @Spring Boot application, and need to create the main method and
Looking to take the next step in your career? Then you have to get this AWS course on Udemy.
Spring application dot run, give the class name. Fine. So we created three modules, and we created main class for order service and payment service. We are not writing the main class for common DTOs, because we just need to write the DTO and event classes here. Okay, we are not going to start this common DTOs application. Okay, so what I'll do, I'll just add a configuration. Just click on this, type Maven, then I'll give it something like Saga build. Working directory will be this main, then command line I just want to clean install. Okay, go to the runner. I just want to skip the test case while executing the build. Click on apply. Okay, now just build it. It will take a couple of minutes to complete the build. It got failed. So on project common details. Okay, so it is expecting main class in common details as well. Okay, so what I'll do, even though we'll not run this application, but let me write a main class here, new package, just add it, com javatechie saga.commons, click on OK. Now let me create a main class. Let's say Java class commons DTO application. I'll simply just add main method, because we didn't add any dependency in common DTO's POM. So we don't need any Spring Boot related class here. Okay, save it. Now let me run the build. So it will take few seconds to complete. Yeah, so if you observe, the build is completed. Saga choreography pattern, order service, payment service, and common DTOs. Okay, so this is what we just created multi-module project for our Saga choreography pattern. So in my next tutorial, we'll just implement entire code. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.
পছন্দের ভাড়া অফার করুন বা আপনার পছন্দ মতো ড্রাইভারের অফারটি বেছে নিন। এখন অ্যাপের নয়, আপনার উপরই সবকিছু।
দাদা তাড়াতাড়ি চলো, এবার আমাদের রাজ্যের পালা।
খেয়েই যাচ্ছি। অ্যাসিডিটি।
কেউ ওকে জিরে দাও
আর জোয়ানো।
কালো নুন মিশিয়ে দিন।
এসবের চেয়ে ভালো নতুন 3-in-1 এর ইনো খাওয়ান।
এতে আছে 3-এর শক্তি, যা অ্যাসিডিটি থেকে দ্রুত মুক্তি দেয়। 3-in-1 এর ইনো, 3টেই এতে আছে।
Hi everyone, welcome to Java Techie. In previous tutorial, we understand what is Saga choreography design pattern and its internal workflow. Also, we created project skeleton, right? So in this tutorial, we'll complete the implementation part. If anyone is not aware about what is Saga and its use case, then I would strongly suggest you to check out my previous tutorial. Otherwise, it will be tough for you to understand this implementation part because I will write the implementation as per the workflow which we discussed in our previous tutorial. Okay, so let's get started. So if you can remember, this is the exact project skeleton we created. Let's begin with the common DTOs so that we'll add couple of DTOs and events class so that we can reuse those DTO and events in order service and payment service. Now let me go to this DTO package, main, then go to the Java, then go to the package. I will create a package called DTO. Similarly, I will create another package called event. Okay. Now let me create couple of DTO class. Since we are processing the order, I will create a DTO class called order request DTO. So I'll name it order request DTO. Similarly, I can create a class called order response DTO. Just create a class order response DTO. Fine. Let's go to the order request DTO and I'll add couple of field: user ID, product ID, amount and order ID. So while purchasing a order, user must need to pass these 4 fields. User ID he need to pass because based on that user ID we need to validate the available amount in payment service. Similarly, he need to pass the product ID, which product he want to purchase and what is the amount of that particular product, and order ID will be auto generated through the system. Okay, so as we added Lombok, we don't need to write getter and setter manually. So what we can do, we'll just write @data. Okay, so Lombok annotation is not showing. Let's go to the pom.xml. Yeah, so we just need to add the Lombok dependency. Now once you added the dependency, just go to the folder and just do on Maven re-import. Okay, once import completed, then go to the DTO. Now if you type @data, you can see the annotation, right? So you just need to add @data, then we just want all argument constructor. Also you want no argument constructor. Fine. Now similarly, let me create couple of field in our order response. So just go to order response DTO and I will use the same field which I just want to return as part of response. Also I just want to return order status. Okay, so I'll just write order status. So I just need to create a enum with this order status. Okay, so I'll just create a enum inside this event. So just go to new, then click on Java class and let's change it to enum. Then I'll just add it order status. So as part of this order status, I just want to show, let's say, order completed, then order cancelled. Okay, what else we can add? Order created, right? So what I'll do, I'll just follow the order. So the first step will be order created, then either user will get order completed or order cancelled. Okay, so this is what my enum. Now let's go to order response DTO. So let me import this class. Fine, it import from the event. Similarly, let me create another request DTO for payment. So I'll just create a Java class. Let's say payment request DTO. Then here also I will just add couple of field, order ID, user ID and amount. So in payment request DTO, we must need to pass this user ID and amount. Okay. So that based on that particular user, what is the exact amount available in user balance table, you can validate in payment service. So these are the field we need to pass as part of payment request DTO. So I'll just add annotation at the red data. We just need all argument constructor. We just need no argument constructor. Okay. Let's copy this and I'll add same in this order response DTO as well. Fine. Now let's move into the event creation. Okay. So let me close all. Now I'll just create a event called order event, something like that. Let me create a class. So I'll name it order event. Similarly, we'll create another event called payment event. Okay. So I'll just create a class called order event and here I will just send the request order request DTO and order status. Okay. So I'll just write private order request DTO. Let's say order request DTO and I just want to pass private order status, which is the enum we just created, right? Fine. So as part of each event, I just want to pass the date of that particular event and I want to generate some random event ID. So what I'll do, I'll just write private, let's say UUID, event ID. I'll create something like UUID dot random UUID and date. I'll just pass the current date. Let's say I'll just add private date equal to new date. Fine. So I just need to pass this as part of order event and as well as the payment event. So let me create another class. Let's say Java class payment event. Okay. So here also I need to pass this event ID and date. So instead of adding it manually, what I'll do, I'll just create a interface. Let's say the interface name is event. In event, I'll just write two methods. Let's say UUID get event ID or something like that. Then date util date get date. Okay. So then go to the order event and I will implement that from event. Then I just need to override these two methods. So as part of this get event ID, I'll just send this. Then as part of date, or you can name it event date. Just written here. Fine. Similarly, I just need to pass these two fields as part of this payment event. So I'll just add it here. Then I'll just implement from event. Then I will just set these two fields. Let me override. Let's say event ID and event date. Similarly, as part of this payment event, I just need to send private payment request DTO and also I just need to pass payment status. Okay. I'll just create another enum. So let me copy this. Then I'll just create another enum. New Java class. I'll change it to enum payment status. So in this payment status, I'll add something like payment success or complete, anything you can write. Okay. Then I'll just write payment failed. Okay. So better we'll change it to payment completed because it should be in past tense. Payment completed, payment failed. Fine. Now go to the payment event. So we added all the required attributes related to our event. Now to build this order event, what I'll do, I'll just not write the Lombok related annotation, I'll manually write the constructor so that I can pass only these two fields. So what I'll do, I'll just add the constructor, just write generate, then I'll just use the constructor. I just want these two fields. Okay, just add OK. Similarly, I'll just create another constructor for payment status, payment event. So I also just need to pass these two. Okay, so I'll just create a constructor, generate, then constructor. I'll just add these two fields. Fine. Also, I just want to add default constructor. So what I'll do, I can directly add here no R constructor. Here also I will just add no R constructor. That's fine. So we successfully created all DTOs and events. So we are done with our common DTOs. Now we just want to reuse this common DTOs in order service and payment service. So for that, what I need to do, we just need to add these common DTOs as a dependency in order service and payment service. So let's go to the order service pom.xml, and then I'll write another dependency here. Let's say dependency, then artifact ID I will specify common-DTOs. Okay. Then group ID I will specify com java techie common DTOs. Okay. So let me format it. Same dependency I just need to add in payment service pom.xml as well. Go to the payment service pom.xml. Then here also I just need to add the same dependency. Fine. So once you change in your pom.xml, always remember to do the maven re-input. Okay. So that the changes will be reflected in your code. Now let's start writing the code for order service and payment service. So let me close this. Let me go to the order service. Let's create a couple of packages here. So I'll just create a package called, let's say, entity. Okay. Similarly, I will just create another package called service.
উবারে সিট বুকিং কি আরামের দিনকাল। আমাদের স্ট্রাগলের সময় না বাসের ভেতরে ঢোকা থেকে নিয়ে বেরোনো পর্যন্ত বোঝাই যেত না হাত আর পা ঠিক আছে কিনা। সিট ধরা চক্করে ঠেলা ঠেলি গুঁতো গুঁতি, ওরে বাবা, তার জন্যই তো এত সলিড হয়েছি জানো।
এখন চাই না আপনার ঠেলা ঠেলি গুতোগুতি।
স্ট্রাগলের দিন গেছে বেড়ো, এখন আরামের দিনকাল। সল্টলেক সেক্টর 5 এলে না, উঠিয়ে দিও।
Uber shuttle, no struggle.
Then we'll just create a package called, let's say, repository. Then we'll create a package called controller. Then I'll just create another package called event config, something like that. Okay, so I'll name it config only. Fine. Then let's start creating the entity. So I'll just create a class. Let's say I'll give the name something like purchase order. Okay, so I'll just annotate here @entity. Then I will just specify table, and I'll specify the name of table. Let's say purchase order TBL, something like that. Okay, so here I will just add private integer ID. Then I will just add user ID and product ID. Okay, then also I will just add price, private integer price. Then I just need to add the order status and payment status. So this is my entity which will be stored in a database. Usually when a user will try to purchase something, then also you just want to capture the order status of that particular order and payment status. So that's the reason I just need to add this field, order status. So if you observe, this order status is coming from different folder, which is common DTOs or different module, you can say, right? Just add it, order status. Then I will similarly add private payment status. Fine. I just need to add this @ID, and I want it to be auto generated. So I'll just add generated value. Since these are the enum, to store this in database, I just use something called enumerated. Then I just need to specify the type of it. So I can write something like enum type, okay, dot string or something like that. Yeah. So let me copy same for payment status. Fine. So I just need to add @data, then all argument constructor. I will just add no argument constructor. Fine. Now let me create the repository for it. Let me create a Java class. So I will change it to interface. I will name it, let's say, order repository. I will just extend it from JPA repository. So let me type JPA. Yeah. So I just need to add the model as a purchase order, right? Then data type integer. Fine. Since we are using JPA with MySQL, so we just need to add few properties related to our data source, right? So inside the resource folder, I'm creating a file called application.properties. I'll just add this attribute: driver class name, URL, username, password, show SQL to see the SQL statement in console, and Hibernate DDL auto, we just make it update, and dialect and format SQL. Okay, so these are the attribute I just added to make data source up and running in this application. Fine. Then let's start writing the controller class. Okay, so just create a new class. So I'll name it order controller. Fine. I just need to annotate here @REST controller. Then also I can use the request mapping, which will be act as a root URL. So I'll just give, let's say, order. Then I just need to write a endpoint. So let's quickly write a endpoint to create a order. So I'll just write public. I just want to return the entity itself. So I'll just return purchase order. The method name, I'll name it create order, and it will take the input as a order request. Okay. Order request DTO. And we just need to annotate @request body, because this is the post mapping. Fine. Then I just need to annotate here @post mapping and give the URL something like create. Fine. So what I just need to do, let me go there. So if you observe in this order request DTO, we have the field called user ID, product ID, amount, and order ID. To process a order transaction, we need these are the field. That's why I just added as part of the request body. Okay. Then I just need to call the service to create that order. So what I'll do, I'll just create a class called order service. So let me go to the service package. I'll just create a class called order service. Fine. I just need to inject this order service inside this order controller. So I'll just write private order service. Then I just need to use auto add to inject it, right? So I can directly return here order service dot create order, and I will just pass this order request DTO. Fine. So I just need to create this create order method inside this order service. So let me create this method. Fine. Now in this order service, I just need to inject my repository, right? So I'll just use private order repo. I'll just use auto add. Now I just need to convert this DTO to entity so that I can directly save this order repository, this particular order object, which is the purchase order, right? So what I'll do, I'll just use order repository dot save. I'll just give this order request DTO, but it will not work, right? I just need to convert this order request DTO to this purchase order. Then only I can save it. So I'll just write a method. I'll just write a private method here. Private will return me the purchase order object. Convert DTO to entity, something like that. And we will take the order request DTO. Fine. So ID will be auto generated. We are not going to add the ID manually. Apart from ID, we just need to set the other attributes. So I will just change it to DTO. Then I will just add this piece of code. We'll create the object of purchase order, and then from the DTO we'll get the value and we'll set it to the order object. Okay. So let me import this. Fine. So the initial status of order is order created. So that in background we'll run the other logic to validate the user balance in payment service and all this stuff. But initially user will get this message, your order is created. Then based on the availability of credit limit, the status will be changed, order cancelled or order completed. Okay. Now what I'll do, I'll just call this method convert DTO to entity, and then I'll just pass this order request DTO. Fine. So it will save the order object in database and it will return the order object. So let me capture that. Let's say order. Fine. So what next? I will just set this order ID to this order request DTO object. Okay. So what I'll do, I'll just write order request DTO dot set order ID. I'll just give this order dot get ID, which will be auto generated, right? So that the entire transaction will be in a single track. This order ID will be mapped in everywhere. Okay. Now the next step, we just need to publish an order event. So if you remember the diagram, initially when order service receive a request, immediately he just need to produce an event to this topic, right? So the topic name will be order event, and once order service receive the create order request, he just need to publish that event to the particular topic. So what we'll do, let me go to the IntelliJ ID. So I'll just write here produce Kafka event with status order created. So that's the status will be published to the order event topic. Okay, so if you go to the diagram, once user order service receive the request, immediately it will publish the event to this order event topic, and from this order event topic, payment service will consume that event and he will validate the user balance. Okay. So what we'll do, we'll just create a separate producer class. So I'll just create a separate class. Let me create a class called order status publisher, something like that. Fine. Then I will just annotate this at the rate.
AI is slowly taking over and making our lives easier. From chatbots to weather prediction systems.
Service, you can annotate at the rate component as well. And then I just need to use sync.many. Sync is a publisher who will just help to emit the event. Okay. So I'll just use, if you are familiar with Webflux, you should aware about this sync. Okay. So syncs, if you observe reactor.core.publisher. So just use this dot many. Okay. Then just specify what you want to publish over the Kafka. So I just want to publish over the Kafka this order event. And if you will go inside this order event, it contains the order request DTO and order status. So just go back. So I'll just name it order syncs, something like that. And I just need to use @AutoAdd to inject that. Then I will just write a method public void publish, let's say order event or something like that, order event, and it will take the argument order request DTO and order status. Fine. And with this value, we'll just need to create a order event object. So I'll just create order event equal to new order event, and I just need to pass this order request DTO as well as order status. Fine. Then we just need to emit that event. So to emit that event, what I need to do, I'll directly use order syncs. There is a method something called try emit next. I can use this, then just use this order event. Then go to the order service, and here you can simply write order status publisher. Okay, first I need to inject that. So I'll just use private. Let me close this. Yeah, I'll just use private order status publisher, then order status publisher. I'll just inject using AutoAdd. Then I can directly use that value. Order status publisher dot publish order event, and just pass the order request DTO, and then just pass the order status as order created dot order created. and then just return the order request purchase order object to the user with the status your order is created. Okay, so what I'll do, I'll just return this order. So once again, if you observe, we are just persisting that order object to our database with order status created, and then immediately we are publishing an event to order event topic so that payment service can consume that. So this should be executed in a single transaction. So we just need to annotate @transactional. Okay, so let me format this, and also I'll just write another method to view all the purchase order. So I'll just write public will return me the list of purchase order, get all orders, something like that. Then I will directly return order repo dot find all. Then I will directly go to the controller. So I'll just write another endpoint public, let's say will return me the list of purchase order, get orders, directly use return service order service dot get all orders, and simply just annotate here @get mapping. That's it. I don't want to add any child URL for this. Fine. Now since we are already publishing the event from the order status order service using this order status publisher, again we need to write a code to publish through the Kafka. Okay, since we are using Spring Cloud Stream, the approach is straightforward. What I'll do, I'll just create another config class, Java class. I'll name it order publisher. Then what I'll specify something like order publisher config. Okay, then I just need to annotate this @configuration. Fine. Then I just need to write sync. So I'll write public syncs of many of type order event. Then I'll name it order syncs. Fine. Then I'll simply return syncs dot many dot multicast. What else? Let me check that. On back pressure buffer. Okay. Then I just need to annotate @bin. Now the actual Kafka publisher I'm going to write here now. So just write public who is going to supply flux of order event. Okay, so that's the reason I'm just using supplier from Java 8 functional interface. So if you know Spring Cloud function, then you can write this functional style coding. So as part of supplier, I just want to publish flux of order event. Okay, then I'll name it order, copy this. So I'll declare it will return this. Now I just need to annotate @bin. So if you are not familiar with reactive programming approach, you may find this syntax is complicated. Just go through the Spring Boot Webflux documentation. At least you can get some clue about these methods. Okay. Now we just configure the publisher and everything. Now how my application order service will get to know who is my publisher and what is the topic name, that we need to inform to this order service. So for that, just create a file called application.yaml. Here, since we are using Spring Cloud Stream, you can directly write we are using Spring Cloud function approach, right? In this function, so I will just write by the method name who is my is going to publish. Okay. Then next step, we just need to specify the bindings. So just Spring Cloud Stream consumers, right? My number. Fine. Then we just need to add the destination, which will be your top. That's why here you just n number of supplier out, and you can specify 0 or 1 n-gram orders you are specifying. Okay. So if you observe this diagram, order service will publish the event from the to the order event topic, and payment service will consume that. Similarly, payment service will produce the event to payment event. Again, order service is going to consume that payment event topic. Okay. So as of now, I am not configuring the consumer here because we'll move to the payment service. We'll go with the flow. Then we'll at the end, we'll just add the consumer in this order service. Okay. Also, I'll just specify the server port, let's say 8081, something like that. So we are done with our order service. Now let's move into the payment service who will listen to this order event topic. Okay. So just go to the payment service. Here also we just need to create couple of packages. So let me close everything.
Hey.
Hi.
So can you make a website using Python in 15 minutes?
In 15 minutes? Impossible.
It is possible.
And how is that?
So by using AI with Python, I can write my code using AI and debug in minutes. It saves 95% of my time when coding a website, visualizing and...
I'll just create a package called entity. So I'll create a package called entity. Similarly, I create another package called service. Then I will just create another package called repository. And then I will just create a package called config. Then quickly create a entity called user balance. So just create a class, Java class, name it user balance. Fine. I just need to annotate @entity. Then I just need to annotate @table, but let's ignore it. Based on your class name, it will create a table. So I'll just add few field. I'll just add private int user ID. Okay. Similarly, I will just add private int price. If you observe the diagram, guys, I am going with the flow, so there will be no way to distract from the flow. So try to focus the code. Okay. So if you observe in this payment service, we are maintaining user ID and amount, right? That's what the entity I am creating here to validate the user balance. So what else? I just need to annotate here @ID. That's fine. Also, I will just create another entity called user transaction. So let's say Java class user transaction. I'll just annotate @entity. So what I'll do, I'll just write here @data, all argument constructor, no argument constructor. Okay, go to the user transaction. Then let me add few field here. Private integer. I just want to map order ID here so that the user transaction will be rolled back if there is something going wrong in the payment processing or payment is not available, and we can keep track that using this order ID. And also I'll just add few field user ID and I'll say it amount. So what I'll do, just add this as a @ID, and here also I'll copy the same annotation, just add it. Similar way, we just need to create repository for these two entity, right? So I'll just create, let me copy this user balance class name. I'll create a class. I'll create an interface itself. I'll name it user balance repository, and then it will extend from JPA repository. So I will give it user balance as my model name, and then the data type is integer, right? Similarly, I will also create another repository for this user transaction. So I just copy the class name, create a separate interface. I'll name it user transaction repository, then extend it from JPA repository. Just give the entity class user transaction, then data type of your primary key, which is integer, right? So we created two entity and also we created corresponding repository. Now let me close this. What we need to do, we also need to configure the data source related properties in this application.properties file, right? Create a separate file. application dot properties. Then I'll directly copy from here. So go to the payment service application dot properties, just paste it. That's fine. Now if you'll go to the diagram, so let me erase it so that I can explain you again. So the first step we already completed. Order service will publish the event to this order event topic. Also we configured this order event and order supplier in our application.yml file. Now the next step, this particular order event will be consumed by this payment service, right? So we need to write a consumer in the payment service. Also, if you observe, payment service will consume the event and also it will do some validation. Then again, it will just produce a event to another topic, right? So the first step will just consume the event from payment service. This is the event. So let's write the separate consumer in this payment service. Now let's go to the IntelliJ IDE, go to the config. I'll just create a class. Let's say payment, something Kafka config or something like that. Or I can specify payment consumer config. Okay. So I'll just specify @configuration. Fine. So in this payment consumer config, it will consume the order event and again it will publish the payment event, right? So once again, if you go to the diagram, in this payment service, it will just consume the order event and it will publish the payment event. So to perform that, what I'll do, I'll just write a method here, public, who will consume the order event, right? So I'll just write consumer, but if you will use consumer, but if you will use consumer, we cannot perform two argument, right? So I will take it function. So if you observe, function is also came from Java util function. So this will be part of Java 8. So as part of function, I will consume flux of order event. Okay. So I'll just specify order event. And also I will just publish flux of payment event. So I can write something like flux of payment event. Fine. So I'll just name it payment processor. It will consume the order event from the order event topic and it will process the data. It will validate the payment, and once everything okay, it will just publish another event, payment event. That's what we are doing here, right? So let me clear it once again. So it will just consume the order event and it will validate something. Again, it will publish the payment event. That's what we configured here. Okay. So let me make it capital. Fine. Now what we'll do, we'll get the order event, right? Let's process it. So I'll just use order event flux. Okay. Then order event flux dot, I'll directly use the flat map and I'll use another private method to process that. So what I can do, I'll just create a separate method. Let's say process payment. I'll just create this method. Fine. So this will take the order event and it will return the, so let me remove this. It will just return mono of payment event. Okay. Also just annotate here @bin so that it will act as a both publisher and consumer. Okay. Now in this method, what we are going to do, so let me write the algorithm so that it will easy for you to understand. Get the user ID, then check the balance availability. Fine. If balance sufficient, then payment completed. So I'll write something like this, payment completed, and deduct amount. Okay. Deduct amount from DB. If payment failed or payment not sufficient. Then simply cancel the order event, or what you can say, cancel the order event and update the. So let me close this. Yeah, this is what the algorithm we are going to write here. Okay, so what I will do first, I will events. Go to the order status. I can directly go back. So this is the enum, right? Order status dot order created dot equals the status we are getting from the order event. It means if you go to the order service, let's go to the order service. Here we are publishing the event, right, with order status created. If it is created, then we are going to process it in our payment service. So let's go back here. So I'll directly do something like order event dot get order status. Okay, there is no getter method. Go to the order event class. I will just annotate here @data. Similarly, go to the payment event and also I will just add here @data. Okay. Now go to the payment consumer config. So here I'll just check order event dot get order status dot get. So we can simply validate here, right? Order event dot get order status will give the enum and we are validating with the enum. If the status is order created, then what we need to do, I will just use return mono dot from supplier. Okay. Then I will just write a service method and I will execute this piece of logic. Okay. So what I will do, I will just create a service call. Let me create a service first. So go here, let me create a class called payment service. Okay. Then I will just annotate here @service. Then go back here. I just need to inject that as well here, right? Private payment service. What is the mistake? Okay, I just need to refactor it, right? So I'll just use Shift F6. It should be capital. Class name should be starts with uppercase. So I'll just use payment service. Then I just need to use auto add. Fine. Then I can directly write that method. This dot payment service. I'll write a method something like new order event. Okay. And then I can directly pass this order event. So let me close this. That's fine, right? So now let's create this method. Similarly, go to the payment consumer config. Else, I just want to return mono of from supplier. I'll just use another method to cancel order event. This dot payment service dot cancel order event. So just give the event here. Create this method. Fine. So we are good in our payment consumer config. This will consume the event from order event topic. That's what we understood as part of our presentation, right? And this is what the algorithm we are going to perform in our payment service. If order status created, then create the new order event and update the user balance in database. If there is something going wrong, payment is not available or amount is not available for that particular user, then cancel that order event and update the amount in the user balance DB. That's what we are going to do. So let's go to the payment service and let me change the return type. This will return me the payment event. Okay. And in this cancel order, I can directly return the bird. I don't want to display anything or I don't want to return anything. So as part of this payment service, I just need to inject both the repository to perform the database logic. Right. So what I'll do, I'll just use private user balance repo. So I'll just use user balance repository. I'll just use auto add. Similarly, I just need to use user transaction repository as well. Private user transaction repo, then use auto add. So initially, if you go to the user balance, let's go to the user balance entity. We have user ID and price, right? Initially, let's dump some dummy data to this user balance table at the time of application startup. So let's go to the payment service. What I'll do, I'll just write a method public void init.
So you think you might be a great project manager, but you need to enhance your skills? Then get this course on Udemy. You'll learn the tools and techniques.
Okay, I'll just write user balance in DB. Fine. So let's make it uppercase. Fine. I'll just use post construct. So this annotation is replacement of init method. This will execute at the time of application startup. So what I'll do, I'll directly use user balance repository dot save all. Okay, I'll just add something stream of couple of user object. So just import the class, import this class, then convert this to list. Fine. At the time of application startup, these are the entry will be stored in this user balance table. Okay. Now what next? Let me go to this payment consumer config and let me copy this. Why this is crying? So let me check. No instance of type. Okay. This should be from runnable, not supplier. Fine. Now go to the payment service. Let me add this logic so that I can explain you while writing the code. Fine. Just let me add this. First get the user ID. We'll get the user ID from this order event, right? So from this order event, what we can get? If we'll go to the order event, we can get the order request DTO who have user ID, right? Let's go back. Let's get that order request DTO.